and how they work. And we'll actually be looking at the architecture and packaging of the Toyota Mirai as an example to see how this is actually implemented within a car. Now, before we get into the Toyota Mirai and how this is actually packaged, we need to know how hydrogen fuel cells work and how they produce electricity. So here we have a hydrogen fuel cell, and it may look a bit complicated at first, but they're actually rather simple. So what we've got going on the left side, we have a hydrogen supply, and on the right side, we have an oxygen supply. So this hydrogen, the first thing it passes through, basically it passes this platinum catalyst, and what this platinum catalyst does is it separates the hydrogen from the electrons. So the electrons are split off, and now we have two positively charged hydrogen atoms. Now the next stage is to pass through the proton exchange membrane, and this is only going to allow for positively charged things to pass through. So here we have these positively charged hydrogens, so they can pass through, but the electrons cannot, nor neutral charged items. So as these hydrogens are passing through, the electrons have to go somewhere else, and that's where they're going to travel and power whatever it is that you're attempting to power, whether that be a light bulb, an electric motor in this case, charging a battery, sending that power to a controller and letting the controller distribute it where it needs to go. The point is those electrons are going to travel through something, thus providing electricity, and then they're going to come back after the hydrogen atoms have passed through this proton exchange membrane. So after the electrons have gone and done their thing, they'll return to the fuel cell, where they then combine with the positively charged hydrogen atoms to form H2. Now you have an intake air supply, which of course contains oxygen, and so the H2 will then bond with the